In our last lesson, we learned about the specific angle pairs created when a pair of parallel lines is cut by a transversal. Before we move on, let's review. Most of these angle pairs are named based on the location of the angles. So the first way to describe their location would be in regards to where they are compared to the transversal. Remember, the transversal is the line that actually cuts through those parallel lines. Okay? So the first way to describe them would be if they are on alternate or opposite sides of the transversal, or if they are on the same side of the transversal. So you can see that C is on one side, E is on the other. So those are alternate to each other, where D and E are both on the same side of the transversal. The other way to describe them would be where they are in comparison to the parallel lines. So the first one we're going to review is if they're on the exterior of the parallel lines. So instead of in between, they're on the outskirts. The opposite would be interior. So those this time would be happening in between those two parallel lines. So most angle pairs are going to be a combination of the two. Something like alternate exterior angles or same side exterior angles. Let's quickly recap those as well. We have a couple of throwbacks mixed in here as well. Remember, supplementary angles together make a straight line, and they're 180 degrees. So I have a lot of different examples up here. The first ones that I saw were angle 1 and angle 2. Together, those create a straight line, so I know that they are supplementary and together equal 180 degrees. Remember, vertical angles are across from each other. Again, I have a lot of different examples, but the one I'm going to make note of is angle 1 and angle 4. They are across from each other in those pair of intersecting lines, and I know that they would be equal to each other. Then come my new ones, alternate exterior angles. So alternate, I know I'm looking for things on either side of that transversal, and exterior, I'm looking for something on the outside of my parallel lines. So let's look at angle 2 here. If I look at angle 2, that's on the exterior. So on the opposite side of the transversal would be angle 7. So those would be my alternate exterior angles. Next up, I'm looking for alternate interior. So I'm going to switch my focus to the inside of those parallel lines. So the first angle that I saw was angle 3. On the opposite side of the transversal as angle 3 would be angle 6. So together, those are alternate interior angles. Next up, let's look at same side. So this time they're going to be on the same side of that transversal. If I look at angle 1, on the exterior, but the same side would be angle 7. And if I look at same side interior, let's say I look at angle 4, that's on the inside. To the same side of that, but still interior with it, would be angle 6. We'll keep practicing that today. So the only new thing that we're going to cover today is one additional type of angle pair. And to help us introduce that, we're going to kind of throw it back to something that we know how to do. So here I have just two intersecting lines together. They create 4 angles. And I want to know what the other angles are. There's a lot of ways to kind of argue your way through this. I think for me, if you're comfortable with vertical angles, that's the easiest. So if this is 120, the angle vertical or across from that would also be 120. And then using supplement angles. So here's a straight line, so that means this angle would have to be 120 supplement, which makes it 60. And then using vertical angles again to argue that that would have to be 60. So what we're going to look at today is if we extend that into a more complex diagram, and I'll quickly write in the answers from the top one. All right, so if we look, all we really did was add an additional line underneath this first one. So we added a parallel line to it down here. And if we look at what's happening, I essentially have 2 angle groups. I have this top one here. Maybe I'll call that A just for reference later on. And then I have this bottom one here. And if I look, the angles at A and the angles in B are the exact same. And each one kind of matches up to one in the other group. So if I look first at this 120 degree angle that I started with, if I look, it's in the top left of A. Well, there's also a top left of B, and that would mean that this angle is going to be the same. So it's also going to be 120 degrees. And I can keep matching these up. So let's see. This one here, this top right, would match up with this top right. This bottom right here would match up with this bottom right. And then the bottom left here would match up with this bottom left angle here. And so that tells me what each of those angle measures would be. This would be 60, this would be 60, and that would be those 120 degrees. So we can see that each one matches to something else. When they match spots or match locations, we call those corresponding angles. And corresponding is just the fancy way to say that their locations match up. So in the two groups of angles that we have, match up their locations. You heard me say things like top left, bottom right, and I matched those to each other. We're going to do one more example before you try these on your own. Corresponding angles match up in location. So in each pair of parallel lines cut by a transversal, I have two groups of angles happening. Here, I can call that group A if I wanted to, and then here I have group B. In each group, I have 4 angles, and I can kind of describe their locations accordingly. If I look at angle 1, that's like in the top left of group A. So it would correspond to the top left in group B, which hopefully you can see would be angle 5. Angle 2 corresponds to the top right location, so it would match up with the other top right location, which is angle 6. Angle 3 in the bottom left matches up to angle 7 in the bottom left, and in the bottom right, angle 4 corresponds to the location of angle 8. So corresponding is really a fancy word to say they match in location. So what you're going to be doing today is a combination of practicing identifying those old pair of angles, so things like alternate exterior, alternate interior, and then the addition of identifying corresponding angles today as well. Good luck!